In this video, we are going to have a look at on how to solve problems involving buffer solution. So let's say if the question gives the concentration of the salt and the weak acid or weak base and there is no volume mentioned. For example, the question asks you to calculate the pH of the buffer solution composed of 0.12 molar benzoic acid and 0.20 molar of sodium benzoate. So the Ka for this acid is given. Okay, so it means that benzoic acid is a weak acid. Okay, so first step, write down the dissociation reaction for both acid and salt. So sodium benzoate is a salt which will dissociate in water completely to form benzoate ion and sodium ion, while the benzoic acid, which is a weak acid, is slightly dissociate into benzoate ion and hydronium ion. So since we have a weak acid and salt that contains same conjugate base, so this solution is a buffer solution. So we have here conjugate base, which is our basic species, and the weak acid as our acidic species. So our solution here is acidic buffer solution. To calculate the pH of acidic buffer solution, we are going to use the Henderson-Hasselbalch equation, which is pH equals to negative log Ka plus log concentration of conjugate base or salt divided by concentration of weak acid. So the concentration of our conjugate base is equals to concentration of our salt. Since our salt here will fully dissociate into the benzoate ion and the dissociation of our acid is very, very small. Substitute the value into the formula and press your calculator. You will get your answer 4.42. For the next example, if you are given the concentration of the salt and weak acid or weak base and the volume of each solution is mentioned. So have a look at the question. What is the pH of 25 ml of solution? 0.02 molars of CH3NH2 is mixed with 50 ml of 0.01 molar of CH3NH3Cl. The Kb of the base is given, which is 4.4 times 10 to the power of minus 4. So it is better for you to draw this flask containing the 25 ml of 0.02 molar of base and 50 ml of 0.01 molar of salt. Okay, so the total volume that we got here is equals to 50 plus 25, so we have 75 ml. And then write down the dissociation reaction for both salt and weak base. So our salt will fully dissociate into CH3 and H3 plus ion and Cl minus ion, while our weak base will slightly dissociate into CH3 and H3 plus ion and hydroxide ion. So this is our conjugate acid since it's come from a weak base. Since these two solutions, when we mix it together, it becomes a new total volume. We have to find the new concentration for each solution by using the dilution formula, which is M1V1 over V2. The initial concentration of our weak base here is going to be our M1, and then the volume here is V1. The new volume, which is the total volume, will become V2. Same goes to our salt. Okay, the initial concentration of the salt is M1, the volume is V1, and the final volume, the total volume, is our V2. So this is the new concentration for our weak base and salt. Since our salt dissociates completely, so the concentration of our salt here is equals to concentration of our conjugate acid. Since we have a weak base and salt with the same conjugate acid, so this solution is a basic buffer solution. So to find the pH of the basic buffer solution, we need to find the value of pOH first by using the formula negative log Kb plus log concentration of conjugate acid or salt divided by concentration of the weak base. And then substitute the value and you will get your answer 3.36. After you find the value of pOH, find the value of pH by using pKw equals to pH plus pOH. So the value of the pH of this solution is 10.64. If the concentration of weak acid or weak base is given, but only one volume is mentioned, okay, let's have a look at the question here. What is the final pH of the solution made by mixing 100 ml of 0.05 molar of acetic acid and 2.50 gram of sodium acetate? The Ka for the acetic acid is given. So let's transfer the information from the question into this diagram. So we have 100 ml of solution, 0.05 molar of acetic acid is mixing with 2.5 gram of sodium acetate. So let's assume that the addition of the sodium acetate did not change the total volume of the solution. So the volume of the solution is still 100 ml after you add the 2.5 gram of sodium acetate. So let's write the dissociation reaction for both solutions. So our weak acid will slightly dissociate into the acetate ion and hydronium ion, while our salt will fully dissociate into acetate ion and sodium ion. So since this solution form the same conjugate base, so we have weak acid and salt with same conjugate base, this solution is an acid buffer solution. Find the concentration of sodium acetate by using the mass given. So we need the number of moles of sodium acetate since concentration is equals to moles over volume in liter. And then use the Henderson-Hasselbalch equation, okay, for the acidic buffer solution to find the value of pH. Since concentration of conjugate base is equals to concentration of our salt, okay, substitute the value and you will get your answer 5.53.